Good morning. Today is August 15th, Friday, and we're on lesson 14 of our class. Now we're officially starting our course review, meaning everything in the course has been taught to you at least once, at least, in the time that I had. Obviously, we summarized a lot and had to focus on the most important parts. The rest was up to you. So let's do a little bit of course review. Just a reminder, you do have your assignment number 2 that's due today. Everything else should have been completed already. Yeah, that's about it. Good luck. Complete the second assignment on Unit 4. And if you've already completed that, amazing. You just have to wait for Monday, and then your culminating activity will be available to you then. All right, today's agenda, we got our learning goals. We got geometry, trig, stats, probability, today's work, and then questions. So learning goals, we're going to solve geometry problems. We're going to solve trig problems, kind of go over. Here we have parallel lines, C and C, and then a line that's crossing both parallel lines, an angle, and we have 8 angles here. 1, 2, 3, 4, 5, 6, 7, 8. So this is a situation. Pair of angles that are equal. Each pair of corresponding angles are equal. What does that mean? I'll show you. Each pair of interior angles are equal. Each pair of exterior angles are equal. Each pair of vertically opposite angles are equal. What does that mean? Well, the easiest one, opposite angle theorem, means that when you have two lines crossing each other, any two lines, doesn't really matter, angles that are opposite one another, so in this case, 1 and 3 are exactly the same. So your angles 1 and 3 are the same. All right. What else? We have some other patterns that you can use. There is something called the Z pattern. If you're not sure what that is, it's something that looks like this, where you have a line that goes down, up. Sorry. Start again. Line that goes across, then down, and across like that. It kind of makes like a Z. And the angles that are on the inside of that Z are equal. So angles 3 and 5 are equal. Angles 3 and 5 are equal. So are 1 and 3. So angles 1, 3, and 5, and 7 are equal. They're all exactly the same angle. And then just like that, angles 2 and 4, here I'll choose another color, are equal. And angles 6 and 8 are equal. And 2 and 6 are equal, and 4 and 8 are equal. So when you have a situation with eight angles, you really only have 2 different angles, and all of them are kind of equal in some way, shape, or form. Then there's something else, another rule that you should know, the sum of pair of angles. Each pair of interior angles on the same side of the transversal are supplementary. Each pair of exterior angles on the same side of the transversal are supplementary. Each pair of adjacent supplementary angles are supplementary. What does that mean? First of all, supplementary is a word that means that 2 angles will add up to 180 degrees. So there's something called the C pattern here. This is the C pattern right there. Right, looks like a C pattern. And that means the angles inside the C, 4 and 5, if you add them together, you'll get 180 degrees. Now, C pattern also works backwards, meaning it can be a backwards C. So angles 3 and 6 also equal 180 if you add them together. There's also angles that are on the same line. So what do I mean by that? So this is the same line. angles 6 and 5, if we add them together, is equal to 180. But not only 6 and 5, you also have 7 and 8 that are on the same line, but it's just underneath. So 7 plus 8 will also equal to 180. Similarly, if we do the same line pattern, 1 plus 2 is equal to 180, and 3 plus 4 also equal to 180. So these are a bunch of rules that you can use to solve for a situation where you have parallel lines and a line kind of bisecting them. So use all of these rules to your knowledge to figure out what's happening. Now, I can do an example with some numbers now. Let's see what that looks like. Say I got a line like this. I'm just going to make up the numbers. Very easy. And I only need one number. I only need one angle. Let's start with this angle here. Let's say that this angle is 110 degrees, let's say. From that alone, I can figure out all the angles that are here. All 8 angles, well, all 7 remaining angles. And the way to do that is to realize that, okay, since this is 110 degrees, we know that because of the opposite angle theorem that this angle here is also 110 degrees. And I know that this is 110 degrees, but this is also 110 degrees. Remember, I can use Z pattern there. And this is also 110 degrees, the opposite angle theorem. So I have my 410 degrees. Now, I know that this angle here in green and the 110, if I add them together, it's going to equal to 180. So if I do 180 minus 110, I'm going to get 70 degrees here. So if that's 70 degrees, this is also 70 degrees. And that makes sense here because 70 plus 110 is also 180. I know this has to be 70. I know this has to be 70. That's it. So I started with one angle, and I figured out all 8 of them, or the other 7, I should say. But really, remember, there's only 2 angles that are here. 2 different angles, I should say. All right, here we got some 2D shapes. Oh, yeah, it doesn't work. Let's see if I can... I'm not sure if this will work. Yeah, no, it's kind of blurry. All right, well, these are just some names of shapes. You can zoom in yourself, but you have a square, 4 sides of equal length, 4 right angle corners. You got a circle, 1 curved edge, same distance across any side. That's the diameter. You should know the diameter. Pentagon is 5 sides. The sum of all the internal angles takes us 540 degrees. You have to Google that. Opposite sides on the rectangle are equal. 4 right angle corners. Got a isosceles triangle. You got a kite. Equilateral triangle. That's easy. All 3 sides are equal length. All 3 angles are the same. Right angle triangle. You got a 90-degree angle. Hexagon, 6 sides. Sum of the internal angles is 720. You got a rhombus, you got an octagon, 8 sides. Some of the internal angles is 1080. You got a scaling triangle, 3 sides of 3 different lengths, 3 different angles. Got an oval, quadrilateral, trapezium. So you should know some of these names. Parallelogram. And now we got some 3D shapes. It's a little bit more clear. Got our cone. Cone has 2 faces, 1 edge, 1 vertex. Sphere, 1 face, 1 edge, 0 vertices. Oh, good boy, baby. Tetrahedron. That's pretty cool looking. You got some triangles there. 4 faces, 6 edges, 4 vertices. Oh, maybe I should explain what an edge is. Oh, here. Look at this cuboid, right? All right. So how many lines do you see? 1 line, 2 line, 3 line, 4 line, 5, 6, 7, 8, 9, 10, 11, 12. 12 edges. Edges is, this is an edge. That 1 line. And another line, that's 2. Then that's 3. Then that's 4. Then that's 5, 6, 7, 8. You really only see 9 here. But there's 3 that are hiding in the back. So, and you know they're there. So there's 12 edges. That's what an edge is. And a vertice is different than an edge. This is the vertice right here. 1, 2, 3, 4, 5, 6, 7, 8. So vertice is like a corner. It's the corner of like 3 planes, you could say, 3D. An edge is kind of a line between 2 planes. And then a face, most people don't understand what a face is, but a face is kind of that area. So 1, 2, 3, 4, 5, 6, 6 faces. Here we have a cylinder, 3 faces. You got the curved part, the top part, and the bottom part. There's 3 faces, 2 edges. Boom, 1, 2. 0 vertices. There's no corner. A cube is like a dice, like a die. Excuse me. You got your 6 faces, 12 edges, 8 vertices, just like the cuboid. You got your triangular prism, and then your square base pyramid. Pyramid. Let's move on. Oh, remember isometric drawings? That was like way back in the beginning. They're a method to represent 3D objects on a 2D plane. Angle between the 2 dimensions is 120 degrees. So kind of like you're drawing your 3D little angle, so you can see the top, the front, and the side. Then there were these orthographic drawings. And orthographic drawings are when you have your 3D object, but split into its several 2D views. And usually the correct way to do is to have the top view first and the front and the right side view. And top being this top part here, front being this on the left, and the right side being this part here. So be careful what you think front is and what you think right side is. Scale diagrams, remember scale diagrams? They're used, in maps or blueprints a lot. So they draw it to a certain measurement, and it's exactly a multiplication factor compared to the real life version of this thing. So here we have like a kitchen, a bedroom, a study, so a blueprint of a house. And they measure this to 2, 3, 1.5, 1.5. And this measurement is equal to 3 feet in real life.